how do you write it for 3 marks, right? So why is the gravitational potential near all isolated mass negative, right? So remind it, what was the main reason? Why is it negative? So I'll teach you how to remember this. Now, you don't need to memorize it. So if you have a mass here, and we assume that the infinite point from that mass has how much potential? 0, right? So infinity, the distance to the infinity, potential is 0. And all the points that we are dealing with are below that line. So if infinity is 0 and above that is positive, right? Below that should be what? Negative. So that's one way of looking into it. But there's another more important reason. It's not just because you're below 0, it's negative. It's more because whenever a mass is moving towards the Earth, right? Is it gaining GP or losing GP? Losing GP. And to signify loss, what do we use? Minus. Okay, so that's the main reason it's minus. So 2 reasons you have to say here. One is why is it losing energy? Yeah, but why is it losing energy? No. That's true. As it's falling, it's losing GP, gaining K. But the question is, why is it losing the GP as it falls? Right, it's going with the field. Whenever something goes with the field, too important. Okay, whenever something goes with the field, it loses energy because it's naturally moving that way. And when you want to take it against the field, right, what do you need to do? Provide it energy. So imagine there's wind blowing this way, and I release a ball like this. If the ball goes with the wind, right, you don't need to do anything. It'll just go on its own. But if you want to go against the wind, what do you need to do? Right. So taking a ball up in gravity is like going against the wind. Okay, so that's the main reason. So like a wording type. So first you say that gravitational force is attractive. Gravitational force. Gravitational force is an attractive force, and since the mass moves with the field, the object loses gravitational potential energy. To show Arctic point electrical, I don't think it's necessary, but I think it completes the answer better also. Gravitational force is an attractive force, and since the mass moves with the field, the object loses gravitational potential energy. To show the loss, the value is considered to be negative. Also, we consider infinity to be 0 potential, hence all the points below it are also negative. I intend to do all of them. I plan to do all of them. I took them from random years from 2011 to 19. So yeah, so between that, you'll find the questions from those years. But yeah, my plan is to do all of these because yeah, these are not only for practice, they also have important questions that need to be answered, like this one. So I'll write this down and I'll also add this to your notes, okay? So question to why is gravitational potential negative, right? So the reason behind that is potential if near a mass. Answer now এটা হচ্ছে for 3 marks summarized version এটা একটু details subject. So exam উপরে লিখবে হ্যাঁ it is like I'll give you extra detail maybe এটা 5 marks 6 marks হয়ে যায় তার জন্য exam এ আসলে উপরে লিখবে gravitational it's important that you understand gravitational potential is actually energy, right? So is it scalar or vector? Scalar, right? So the negative here doesn't mean direction. The negative here means what? Loss. Okay, so it is just careful to go. So it's important to note that. So we answered the লেখা লাগবে না তুমি এখানে নোটস দিয়েছি when I'll upload this again ওই তোমার হচ্ছে আপডেটেড ভার্সনের মধ্যে পাওয়া নেগেটিভটা হচ্ছে এটা কপি করে লাগবে বুঝে নাও অ্যান্সার যেটা আছে ওটা খালি কপি করো So I'll just read through this gravitational force and attractive force, and since the points near a mass or all of it, mass experience attractive forces, they're moving with the field, hence losing energy. To denote the loss in potential or energy, we use negative sign. Furthermore, the infinite location is considered to have zero potential, hence any point beneath it will be considered to be negative value. It's important to note that potential is a scalar quantity, and negative sign only shows that there's a loss of energy. That's it. Okay. All right, let's get back to the question. Achke will try to do, if possible, all of them. So it says that the Earth may be assumed to be an isolated sphere of radius that much, with its mass that much concentrated at the center. An object is projected vertically from the surface of the Earth, so it reaches an altitude of that much. calculate what is the change in gravitational potential. Should be 5 marks. But এখানে দুইটা মিলে 5 দিচ্ছে, so এখানে 3 marks দিচ্ছে। কেমনে করবো এটা? How do you do this? Question আমি একটু বুঝাই তোমাদেরকে. So you have the Earth, which is assumed to be an isolated sphere, meaning that there's no other gravity influence in it. The radius of this is 6.4 into 10 to the power 5 meter. I'm directly meter convert করে দিলাম. এটা হচ্ছে the object is assumed to be where? On the surface. So object is at the point here. It is then projected all the way up so that it reaches an altitude of 1.3 kilometer. And well, square. Thank you. 6.4 into 10 to the power 6 here. And the thing is that orable chips taken to an altitude of that. Altitude money key, is it from the center of the Earth or the surface of the Earth? Surface, right? So this extra distance here is 1.3 into 10 to the power 7 meters, right? So you need to find out the change in potential for the object to go from the surface of the Earth to the top. So you need to find the energy for that much. It took out because so far কোনোটা convincing answer আসে নাই potentially যাই question করছি, so it's easy possible না that এটা পারো নাকি. For gravitational potential, are we calculating the value from infinite? But for GP, we are calculating from the center. So how are they two equal? No. For GP and for potential, we actually calculate from infinite, like that. Okay. But the thing is, the difference from here to there and here to there is the same as the difference from here to there and there to there. So basically, you're just finding the values at these 2 points and finding the difference, right? Regardless from where you take it, the difference is going to be the same. Also, when we find GP, we don't actually find GP, we find the change in GP. So change in GP kintu hocche if an object falls a certain height or goes up a certain height, change is the same. So regardless of what location you're taking your change from, the value for the change is going to be the same. So it doesn't really matter whether it's this minus that or that minus that. মানে তুমি সেন্টারটা এটা ধরতেছো না সেন্টার হচ্ছে ইনফিনিটি ধরতেছো। No. Gravitational potential is something else. Yeah, Gm by R. Minus Gm by R. Joule per kilogram. Is it the difference? Yeah, what is the answer? 4.19 into 10 to the power 7. Achha. So first you need to find the value for phi kothai. Phi at the surface. So I'll call that the radius, right? So that's going to be minus Gm by D. RD, did I use further? D is more appropriate. R is actually radius. D is distance, right? So we are taking distances. So minus 6.67 into 10 to the power minus 11 into mass হচ্ছে 6 into 10 to the power 24 divided by the distance is going to be 6.4 into 10 to the power 6. Now, I think I showed you like a derivation of a formula, GM, bracket 1 minus this minus of that, right? You can do that. That's perfectly fine. In fact, that's encouraged. Okay. So it's a problem. If you remember which one I'm talking about is this one. I derived it as well as this. Okay, so if you want, you can directly use this. They're completely fine with that. In fact, Mars team, they actually do this. Okay, but sometimes students will feel like, where did this come from? So I think that if you know how it eventually shows up, you don't need to memorize it. You can come up with it yourself, right? So at the issue high, that should it be D1 minus D2 or D2 minus D1? It doesn't really bother, because at the end, what are you looking for? Change, right? So whatever the number is, you just take that value without the sign. Achha? Anyways, now we'll find it at whatever height it is. So that is going to be minus gm by the height, which is the altitude. So it's going to be the same equation. Just niche value ta hobe hocche 1.3 into 10 to the power 7. Right. So, and then you find the difference in these two. What's the change in phi tahale? Oh yeah, so this one plus 6.4 into 10 to the power 6, yes. Because the distance is always from the center of the Earth. 4.19 into 10 to the power 7. 4.19 into 10 to the power 7 unit joule per kg. That's already said. So 4.19 into 10 to the power 7. $2.1. অন্যকে একটু চেক করে দেখবো কি আসে খালি একটা ভ্যালু দুইটা ডিসটেন্স অ্যাড না করলে মানে জাস্ট এই ভ্যালুটা নাকি ডিফারেন্সটা ওই ভ্যালুটা আছে তুমি ডিফারেন্স বের করছো হ্যাঁ যে এইটা মাইনাস এটা ও না এটা তো হচ্ছে ডিফারেন্স বের করতে হবে না ইউ ওয়ান্ট টু ফাইন্ড দ্য চেঞ্জ ইন পোটেনশিয়াল রাইট চেঞ্জ সো আমরা পোটেনশিয়াল বের করতে চাচ্ছি আমি তো পাশে লিখে দিই দিস ইজ ওয়্যার সারফেস and this is where at a height আমাদের তো বের করতে হবে the difference. Yeah, I think 4.19 into 10 to the power 7 asha uchit. If it's something else, do let me know. Okay, it says the speed of the projection from the Earth's surface, assuming air resistance is negligible. So at what speed should you project it from the Earth's surface? How do you find that? So it's like escape velocity concept. So this is the change in potential. So now first, what do you need to find out? The change in potential in GP energy, right? So change in GP very good. So change in GP is going to be the change in phi times mass. We don't know the mass of this object, do we? No, not a problem. And the change in GP must be equal to what for this to be going up in the air? The K gain, right? So K gain, K lost. So it's going to be whatever value we found, 4.19 into 10 to the power 7 into m equals to half mv square. Where the m? The m cancels out. So that's why you don't need to really bother about the mass. So finally, you get the value of v. How much is the velocity at which you should launch this object so that it can go to that particular altitude directly? 9,200. Okay. 9,200 meter per second. Yeah, I think because if I'm not wrong, the data provided are all two significant figures. So that's why. 4.2, correct. Yeah, taking the 4.2 over. Right, so 5 marks. Taking into standard question, okay? It's not like too difficult, maybe not too easy either, but eglay more or less ask question paper. And the format is like that. You'll have a definition, you'll have some kind of theory, and a math. So if you can somehow tackle the math and the definition, right, you should do better in your A2 than your AS in theory. Okay, because AS said there are too many papers, there are too many possibilities of going wrong. A2 said there's only one paper that you focus in the paper 4. Achha, paper 5 হচ্ছে এখন যদি তোমাকে paper 5 দেয় and ask you to solve it with no prior knowledge to it, right? You should at least get half the marks. Okay, paper 5. It's planning experiments. And IGCSE students should do even better because you had like a paper 6 in your O levels, alternate practical. It's basically OITER A-level version. So a lot of things are very common there. It's the problem is there's a graph, and the graph is based on uncertainty. So graph uncertainty, the graph করতে হয়. That's the challenge. That's what we will be like preparing for. So my point is, overall, which is the paper that you have to focus on? 4. And then if you have a good 4, you'll have like overall good A levels. And if you have a bad 4, even if you did well in your A, so bring it down. Okay, so paper 4 is like everything. Paper 5 generally তোমাদের হচ্ছে স্কুলের মিড টার্ম হয় ডিসেম্বরে। হ্যাঁ, ওই ডিসেম্বর একদমই হচ্ছে 1 উইক করে বিকজ তার তখন লাগে, এখন লাগতেছে না। আচ্ছা, let's move on. Binary starter করাবো, I want to do this one. A chapter শেষের পেজের আগে, মানে পেজ 42, ওইখানে একটু যাও। পেজ নাম্বারগুলো তোমাদের একটু বুঝে রাখি। আমার পেজ নাম্বারগুলো গ্র্যাভিটেশনাল ফিল্ড দিয়ে শুরু হয়েছে, তারপরে পেজ নাম্বারগুলো আর ফাইন। ওকে, সো পেজ 42 তে যাও। এই লাস্টের দুইটা কোয়েশ্চেন একটু চ্যালেঞ্জিং। How do we know that the speed of the projection, like we found, is a change in we found the change in speed, right? Question it becomes 0. How do we know it's the speed of projection? No. Yeah, you could say change, but K lost, right? So now your object could. So let me tell you what this object would do. This object will start from the surface of the Earth, and if you fired this object at what speed? 9,200 meter per second. And the height that we want to go to is how much? From the surface of the Earth, 1.3 into 10 to the power 7 meters. What would this rocket's motion be? Describe the motion till the top. No air resistance. So I'm going to take a graph draw. It's a question that I have been anticipating for a very long time, but it actually is like a very common question. That how does the graph look like? So this is distance, and this is the velocity, meter per second, and this is the origin where the surface of the Earth is like that, right? Can you tell me how the graph look like for this launch? So you launch an object at 9,200 meter per second. It goes and reaches the outermost point there, okay? So what's the graph for velocity time graph here? Zero. Decreasing graph. Yes, that's a good start. It is a decreasing graph. Why? At a decreasing rate. Okay, first of all, let's clarify this. What's the initial speed? 9,200, right? So 9,200. And from there on, does the speed increase or decrease? Decreases, because you're doing work against gravity. But there's a problem though. Problem though, ideally speaking, the graph should have been like this. And at the topmost point, when you reach the height of how much? 1.3 into 10 to the power 7 meters, the graph would be like that, straight line. Do you know when would it have been a straight line? None. No gravity, none. When would it be a straight line? V was squared. Now we don't know. Yeah, when would that happen? If acceleration due to gravity was constant, minus 9.81. So constant when the gradient would have given you like the grade, minus 9.81 J value. But the thing is, it's not constant. And now, can you tell me how the velocity changed towards the end? Would the deceleration be more rapid, or would the deceleration be less rapid towards the end? Less rapid. Why less rapid? Because the further you go away, gravity is getting weaker, right? Do you agree? Yes. And the further you go, gravity is getting weaker. So if gravity is getting weaker, wouldn't it slow you down with more, with less effort? Less effort now, with less intensity? Because gravity is weak, right? So will you slow down as fast or will it take longer? It will take longer, right? So rate কমে যাবে. So eventually, the graph is going to be what here? A curve. And curve-টা কি হচ্ছে increasing curve or decreasing curve? Yeah, exactly. So শেষের দিকে দেখবা যে চেঞ্জটা অনেক টাইম নিচ্ছে. So it'll be something like that. Okay, do you understand why the rate is very high at the start? Because at the start, the acceleration due to gravity is very strong, so it's slowing you down more rapidly. But as you start to go further away, the acceleration due to gravity is getting what? Weaker, right? So it takes more effort to, or longer for you to slow down. That's why it's becoming flat. Because gravity is not as weak or as strong there, right? So এখানে ধরো minus 9.81. আর এখানে minus এত হাইটে অত চেঞ্জ হয় না, বা ধরো minus 9.2 meter per second square. Wouldn't the velocity change less slowly here? Because it's less acceleration or deceleration. So yeah, that's what the graph is going to look like this. So yeah, তোমার যে velocity আছে ওটা কমতে থাকবে, কমতে at the topmost point. What is your velocity? Zero. So it's like throwing a ball in the air. So just that basically. Okay, motion of a bouncing ball মনে ছিল, এই যে গ্রাফটা এরকম হয়ে bounce করে আবার এদিকে যায়, right? So we are talking about these lines. But আমাদের এখানে তো লাইনটা এরকম হবে না, because what's changing? G. Okay, so that's why the graph is not going to be a straight line. Acha, so right, last it. The Earth may be considered a uniform sphere with mass m constant at the center. The satellite of mass m orbits the Earth in such a radius r. Show that the linear speed of the velocity v of the satellite is given by this expression. You need to find out what's the speed of a satellite going around the Earth. How do I start? Guide me through the process. 5. Okay, right, 5. Okay, minus gm by r. Acha, 5f. That's going to be your gp. So minus gmm by d. None of these are right, but go on. This is a completely different topic that you went to. We are dealing with a satellite that's undergoing what motion around the Earth? Circular motion. It's to do with circular motion equations. It's to energy, ball falling, gravity doing work and whatnot, right? So we go back to the Kepler's law. Do you remember the Kepler's law? Kepler's law, I'm not bullying, but basically the idea is that when an object undergoes circular motion around the planet, what provides the centripetal force? Gravity, right? So force centripetal is equal to force gravitational. What is the formula for centripetal force? Very good. And in this question, which one do you think would be appropriate? Yeah, mv squared by r. And what is the formula for gravitational force? G m m by r squared, right? So এখান থেকে small m cancels out, and we get v squared equals to gm r. Or you can r right cancel out divided by r, and therefore we want to find v only, right? So v is going to be what? Root over gm by r. You're struggling a little bit with this chapter. একদম connection হয়নি তোমার এই চ্যাপ্টারের সাথে. This is the easiest chapter we have in A2. Yeah, that's true. So yeah, show me. Okay, so বলো কি confusion questions, anything that you need clarification? No problem. Gotcha. So centripetal force equals to gravitational force, and you just equate and you get your answer, right? For this satellite, write down an expression in terms of g, m, and r for the kinetic energy. Yeah, half mv squared. Just so we can put the one more dichora. Very generous. K equals to half m av square, right? So that's basically g m by r. So কি আসবে GMM divided by 2R. Next question is gravitational potential energy. Huh? GM by? No. Why 2R? Write down an expression. Nah. They're asking for gravitational potential energy at that point. What you're trying to find is the change. Yes, that's potential. Huh. Right, exactly. So tell এটা কি আসবে GP is equal to phi into m. What is phi? Minus GM by R or D into M. So it has to be minus GM by R. এই কোয়েশ্চনটা একটু প্রবলেম্যাটিক আছে, আচ্ছা তোমরা একটু কেয়ারফুলি দেখো because things will get difficult from here. আচ্ছা, what's the total energy possessed by the object at any given point? Yeah, that's it. Okay, so এটা আমি একটু explain করি can total energy কি হবে. So imagine you have a ball here and the ball is at a height. Listen carefully, okay? The ball is stationary and at a height. Can you tell me what is the energy it possesses? Just GP, right? So GP is going to be, let's say, at a value on X. Now, or numbers, 100 joules. Now, as the object is falling, it will lose GP and gain what? K. Can you tell me at this location, midway, right? If I want to find the total energy, what should it be? I don't need to do any math. What should it be? 100. The total energy of a system always remains the same because of law of conservation of energy, right? So 100 is থাকতে হবে. So the total energy here is going to be 100. But as you can see here, আমার তো এখানে GP কমে গেছে, right? So GP টা কমে half হইতে কত আসার কথা? 50. So GP is 50 joules. Where's the rest of the energy? Kinetic energy. So how much is K going to be here as well? 50. So 50 joules. So that means the total energy at any given point is the sum of what and what? The GP and KE at that point, right? So the total energy is going to be sum of total energy, right? So total energy is equal to the sum of GP plus KE. So GP plus KE at that point, which is going to be GM by 2R minus the use করতে হবে, আচ্ছা, GM by R. One by 2R minus 1 by R, right? So that is going to be minus 1 by R. মানে minus GM by R. আমি তাও চেক করে দেখি ওরা কি এটা ব্রেকডাউন করে দিছিল or did they actually did you KE your expression KE plus GP? I mean, check করে দেখি did they actually simplify it or did they keep it this way? Okay. For GP calculation, do we add the minus? Yeah, we keep the minus because acta plus acta plus 0 the net, because you're coming from where? Infinite. Just give me a minute. I mean, a question to clear it. আচ্ছা, meanwhile তোমরা পড়তে করো এই যে the total energy of the satellite gradually decreases. Total energy of the satellite gradually decreases State and explain the effect of this on the radius of the orbit and the linear speed of the satellite. So how does the radius change because of this, and how does the speed of the satellite change because of this? It ain't too tricky. I want you to apply yourselves and try to answer, okay? So I mean, I think heads up, there are some into challenging. A last set theory question is where students usually lose most marks. So we'll try to work on this. Total energy that's lost. Most likely heat or work done against some external force. Space dust or yeah. Radius of the orbit factor of 2. Yeah, ঠিক আছে. So তুমি বলতেছো তোমার হচ্ছে total energy will then decrease. So radius will increase. Why? Yes. Okay. আচ্ছা আমি বুঝাচ্ছি জিনিসটা। বাই দ্য ওয়ে এই জিনিসটা একটু ক্লারিফাই করে রাখি, এটা এভাবে রাখা যাবে না, এটা সিম্পলিফাই করতে হবে। সো হোয়াট ইজ দ্য সিম্পলিফিকেশন অফ দিস? কি জানি আসছিল? 2r or r? 2r, রাইট? হ্যাঁ ঠিক আছে। বেশ আমরা এটা পরে ইউজ করতে হবে, তো সেটাকে সিম্পলিফাই করে নিই আগে আমরা। সো আমি এটা কেমনে বের করলাম? ইটস বেসিক্যালি দিস মাইনাস দ্যাট, whatever you get, okay? So half minus 1, what is it? Is it minus half? So you have to simplify and keep the answer. So anyways, now let's get to our question. So the question says that the total energy of the satellite, total energy is given by energy total is minus g m by 2r, is gradually decreasing. Explain what happens to this value decrease on the radius of the orbit. So the problem is, listen very carefully. If something decreases, right? If the value decreases, is it becoming more negative or less negative? Because our value is negative. We're talking about negative values here. The total energy here is a negative quantity, right? So our darker decrease, which means it will it become more like a bigger number or a smaller number? Yes, that's the problem. It should be a bigger number. Why is it bigger number? Yeah, exactly. Last class বলছিলাম যারা বুঝুন আমি আরেকবার বুঝাচ্ছি একটু দেখো. Let's say my total energy is this is the value for total energy. Let's say it's minus 100 and minus 1000. Which one is the bigger energy here? Minus 100 or minus 1000? Minus 100. So যখন তুমি math এটা বসাবা, math তো আর জানে না তোমার minus exists for and the thing is opposite. Math is actually taking the number for its face value, right? So আমরা এই নাম্বার থেকে কি করতে হবে to get a bigger number? কমাতে হবে, right? Do you get my point? আর হচ্ছে যদি বাড়াতে মানে এটা যদি বাড়ে তার মানে অ্যাকচুয়ালি এনার্জিটা কি হচ্ছে? কমতেছে, ওকে? আমি এটা পাশে লিখি। If ET magnitude, just understand that I am not doing anything physics related here. It's a math thing I'm showing you right now. If ET magnitude increases, ET value key decreases. Magnitude means I'm talking about the number. The number ta jodi beshi hoy, you're actually losing energy. So amar ekhane ora bolche that it decreases, right? So ET value decrease I have to look for ET ekhane ki hocche, increase hocche. And if this increases, this thing that you see here is a constant, right? So what should this do? Decrease. So therefore my radius decreases. A factor of 2 ta actually বলা যাবে না। জানো কেন বলা যাবে না? We don't know by how much ET increases. তুমি বললা না factor of 2, we don't know that because 2 তো ইকুয়েশনের পার্ট, আমার যদি এই যে এটা হচ্ছে ইনটু 4 হতো তাহলে আমি বলতে পারতাম এটা 1/4 হচ্ছে, because it increased by 4 times, so R will decrease by how many times? 4 times, because the two are related in what manner? Inversely, right? But তুমি যে 2টা বলতেছো এটা কিন্তু equational part, so it doesn't actually affect our answer. Our equation that you need to actually deal with is this one: ET is proportional to key. Yes, just 1/R, because a baki j GMM/2 jeta is actually a constant. So my relationship here is between ET and just R. Okay, so yeah, how do we write the answer? Examiner te eto kichu bujhbe na, tumi math khub bhalo paro, they will see what you write, right? So what would you write? Okay, anyone else? How would you describe this in words? Let's say তুমি খুব ভালো বুঝছো, and I feel like তোমরা বুঝো, but তোমাদের অনেক সময় answer যা লেখো doesn't reflect that. And at the end of the day, examiner just sees what you write, not what we discuss. So তখন হচ্ছে প্রবলেম হয়ে গেল। আমি দিলে মার্ক দিতাম, because I know that তুমি ক্লাসে পারো, but examiner doesn't know that, right? So তোমাদের answer হচ্ছে wordingটা উপরে কাজ করতে হবে। So, and especially in A2, it's only just subjective questions, no MCQs, nothing, right? So you have to know how to write your answer. So how do you put this in words? So এটা সিকোয়েন্সে কাজ করতে হবে। Okay, so first you said that ET decreases. এটা কিন্তু কোনো মার্ক পাবো না এটা বলার জন্য, এটা শুনে নাও কি লিখতেছে এখানে। ET decreases বলার জন্য কেন কোনো মার্ক নাই? Because they already mentioned that. I'm not saying anything new here. I'm referring to the question as a start. ওরা বলছে না ET decreases here, এটা কিন্তু কোনো extra point না। But here's the thing: ET decreases, and since energy total is minus GMM/2R, ET magnitude, or এখানে হচ্ছে magnitude বলতে পারো, must what তাহলে increase। এখন এটা কি তোমরা অন্যভাবে ওয়ার্ড করতে পারো? Since there's a negative sign, a decrease means an increase in magnitude, ওভাবে বলতে পারো। But the idea is that ET decreases, and since the equation has a negative, the ET magnitude must increase. Then you say, hence, based on the equation, hence the increase in ET means a decrease in the radius. It's one of those questions. এটা হচ্ছে ওই মাইনাস সাইনটা যদি না বুঝো, the whole thing is like a chain effect and everything is wrong. So minus apply করা শিখতে হবে। Yes. Mhm. As the what decreases, the increases. হ্যাঁ, বাট হতে পারে না যে জাস্ট জিপি চেঞ্জ হয়েছে, কেই চেঞ্জ হয় না, বা হতে পারে না জিপি কমে গেছে আর কেইও কমে গেছে। উই ক্যান সে ফর শিওর কোনটা হচ্ছে। আচ্ছা, একটা কোয়েশ্চেন: if we write it is inversely proportional radius, as ET decreases or increases, yeah, you can say that at the end, ET, but you need to say why ET increases even though the energy is decreasing. কেন? Yeah, because it's negative. That's the main part here. If you can tackle that, right, rest I think you can manage. It's just figuring out the value ta barbe jodi actually come, and that's the negative sign or problem there, and that's what negative signs do to your math. I remember that a question, question, by the way, and over the years, some students have found their way where they just do it normally. They ignore the negative sign. They just do what normally would happen, right? Last answer ki kore deয়, ulta kore deয়, because negative ki kore answer ulta kore deয়, right? So you just think the negative sign doesn't exist, and just try to imagine ki hobe, oh এই যে ET কমে যাচ্ছে তার জন্য radius বাড়বে। That's what's supposed to happen, right? And then because of the negative sign there, whatever you just thought in your mind will now be what to that opposite. So that's also a way of doing it. It's the same analogy we use in charges. If a positive charge goes to the left, right, negative to the right. It's just the opposite. Right, what happens to the linear speed here? Decreases. Yes, why? You use the equation they have provided. হ্যাঁ ওইটাই করতে হবে। দেখো ওরা থেকে ইকুয়েশন দিছে এখানে রেডিয়াসের সাথে, ওইটাই ইউজ করতে হবে। আচ্ছা তুমি বলছিলে কি জানি যে ও না ওইটা দেওয়া হবে, আমি বলি এখানে কি হওয়ার কথা। এখানে তো রেডিয়াস কমে যাচ্ছে, রেডিয়াস যদি কমে যায় অবজেক্টটা কোন দিকে যাচ্ছে? আর্থের কাছে না দূরে? কাছে। আর্থের কাছে কোনো কিছু গেলে সবসময় কি করবে? এনার্জি কেই গেইন করবে না লুজ করবে? তার জন্য লস হচ্ছে। No, no, it's a GP. I'm talking KE. Yeah, yeah. Okay. So the answer here is as the object moves towards the planet, এটা মানে Earth ছিল, the radius decreases and the KE. This is one way of writing it with velocity increases. The other way is the formula they have given you minus G GM by R. So এখানে হচ্ছে রেডিয়াসটা কমে যাচ্ছে as we have figured out from the previous answer, so velocity will increase. Why can't we use the formula in the question? Yeah, we can. That's what I did. Can you explain the last question again? Why like the ET value? Yeah, sure. So let me just do one more recap of this, okay? সবাই একটু এদিকে দেখো। So ওরা বলছে your total energy decreases. I'll call the total energy ET. And what's the formula for total energy? ET equals to minus GMM by 2R. So ওরা বলছে total energy decrease করতেছে, তাহলে আমার radius কি হবে? So if you normally do it, like how students normally would do it, ET decrease যদি করে তাহলে radius কি বাড়বে না? Because what are they to each other? Inversely proportional. But the problem is a minus sign changes everything. A minus sign reverses the process. So if this is decreasing and this is increasing, a minus means this is increasing and then this is what decreasing. এটা আমি বলি কোথা থেকে তোমাদের নলেজটা আসা উচিত ছিল। There was a chapter in math called inequalities, where there's a less than greater than sign, and whenever you put a minus on one side, what does the sign do? Flip over. That concept. যেটা বেশি ওটা কমে যাচ্ছে, যেটা কম ওটা বেশি হয়ে যাচ্ছে। সো এখানে যেহেতু আমরা মাইনাস ছাড়া দেখি যে এটা বাড়লে এটা কমে, রাইট? মাইনাস ইনক্লুড করলে এটা কমে যাবে, ওটা বেড়ে যাবে, উল্টাটা হয়ে যাবে। তো এখন আমাদের কোয়েশ্চেনে কি যাচ্ছে? আমাদের কোয়েশ্চেনে বলছে টোটাল এনার্জিটা কমে যাচ্ছে। সো আমি যদি বলি এটা কমে যাচ্ছে তাহলে এটা বেড়ে যাওয়ার কথা উইদাউট দ্য মাইনাস ইনক্লুডেড। বাট মাইনাসটা ইনক্লুড যদি করে দেয় তার মানে উল্টা হয়ে যাবে, এটা বেড়ে যাচ্ছে, এটা কি হচ্ছে? কমে যাচ্ছে। আচ্ছা, না ইউ মাইট বি ওয়ান্ডারিং এটা বাড়াটা কেমনে পসিবল? ওরা তো বলছে কমে যাচ্ছে, লাইক ইটস ডিক্রিজিং, তাহলে এটা কেন নিব বাড়াটা? লজিকটা কোথায়? এই যে লজিকটা পাশে, -1000 কি বড় না ছোট? Yeah, compared to -100. So to signify that, the minus sign has to be there, and that's why the thing what you think about is the reverse of what actually happens, because the minus reverses it. Can Hannah, you can ignore this, the K part you can ignore, you can directly just narrate the equation here. So you can say that as the radius decreases according to this equation, the velocity increases. That's completely fine. Just the force. Yeah, because when you're finding force, what is it actually? It's the amount of attraction between any two mass, right? So if I tell you that there's a planet and there's a mass and the force is 500, you have no idea what object I'm talking about. If it's a very small object and it's 500, that means the gravity is very strong. But if it's a very big object and it's 500, that means the gravity is very weak. So if you don't know what the mass is, right, it doesn't really help you picture actual interaction. So how can you give a value that includes mass? So what we do is we find a quantity called gravitational field strength. that tells you how much force what object experiences, a 1 kg mass. So now I tell you that a 1 kg mass experiences 10 Newton. And in another planet, the same 1 kg mass experiences 50 Newton. Wouldn't it be now a better comparison? Because you're comparing like for like, 1 kg for 1 kg, right? So that's standardization where you take the force for 1 kg mass is called the field strength. And what is force? Force is the force that acts between any two masses. It is actually helpful, but it is not a good quantity to compare fields. And when we are comparing fields, we can't really use force, we have to use field strength. Okay, so this is the topic. এটা জাস্ট এখানে পাশে আমি asterisk star whatever দিয়ে রাখলাম, তোমরা যখনই রিভাইজ করবা এই কোশ্চেনটা বারবার করবে, বিকজ এই নেগেটিভ সাইনের জিনিসটা এক্সামে যদি আসে, I don't think like on the spot হঠাৎ করে বুঝাটা ইজি হবে, সো প্র্যাকটিস করে যাওয়া দরকার. Rest of the stuff I think are manageable. মানে তোমাদের টেস্টেও আমি প্রোভাইড করছি, তো so when I give you your test paper back I will discuss those as well. There are plenty of questions there. না, পরের টেস্টটা মনে হয় হচ্ছে থার্মাল ফিজিক্সের উপর বেশি থাকবে, পটেনশিয়ালটা থাকবে না. Okay, let's start the next chapter. Go to page 44. Yeah, do just heads up দেখিয়ে আসবে. Page 44. Right, so the first topic we'll be learning is called thermal equilibrium, and you'll find this entire chapter is actually a revisit of your O levels. Okay, when O levels are concept we take them one step further. So it's actually all O level stuff. নতুন কিছু ওরকম নাই. You'll find everything O levels যা করছো ওইখানে শুরু করি, but we end somewhere complicated. Acha? So the first thing we learn here is called thermal equilibrium. Do you guys remember what thermal equilibrium was? Thermal equilibrium, yeah, thermal equilibrium is when two systems are brought next to each other, right? Energy transfer happens between them, and the energy will keep transferring between one another until both of them have same temperature. The moment both of them have same temperature, energy transfer doesn't continue any further. It happens, but net transfer hoy na. So one important concept here is that energy transfer continuously takes place, but when temperatures are same, the energy transfer becomes what? Net zero. So when your both hands are same temperature, right? So if you hold both hands, is there energy transfer taking place? Yes. But is there net energy transfer taking place? No. Net energy transfer নিলে হচ্ছে একটা হাত ঠান্ডা হয়ে যেত আর একটা গরম হয়ে যেত. So the concept that energy transfer takes place from one object to another object until both of them have same temperature is called thermal equilibrium. Can you give me a practical example of this? You do that to transfer energy. Radiator, yes, radiator is like it's cold and the other object is warm, so it takes the energy away, and radiator has certain design features that makes it easy, right? Our simple example cooking food. Cooking food is actually a way, but the most obvious one is the one here, the work of a thermometer. So if I want to measure temperature of something, right? Let's say a water temperature very good to say, you just dip it in and out. কেন কাজ করবে না? এটা thermometer, so it says yeah, so if I just do that, I didn't give enough time to let the system attain what? Thermal equilibrium. Acha, but if I kept it inside, কি হবে? The liquid will lose energy, the thermometer will gain energy. At one point, both of them will have same energy transfer, and that's when both of them have what temperature? Same temperature. So তখন আমি thermometer temperature দেখি must be the same as my liquid here. Okay, so if you remember O level, this was a precaution. We allow and wait for the system to attain thermal equilibrium. That's why সবসময় temperature reading নেওয়ার আগে you have to wait a couple of minutes. Why? So that the system attains equilibrium, right? So yeah, we will look into this and we'll look into the molecular level কেন এটা হয় the next class. Okay. Electric field chapter. Electric field similar, but আমি similar chapter পরপর করতে চাই না, because revision-এর একটা scope থাকে না, আমি গ্যাপ দিয়ে করতে চাই. আমি বলি কেন, because obviously ভুলে যাবো তোমরা. So our couple of few weeks later আবার এখানে যখন ব্যাক করবো তখন একটা রিক্যাপ হবে পরপর করলে আই থিঙ্ক জিনিসটা হচ্ছে ইটস নট রিয়েলি হেল্পফুল যদি স্কুলে করে থাকো ইটস ফাইন বাট আই ফিল লাইক গ্যাপ দিয়ে করাটা বেটার তাহলে ইউ গেট আ রিক্যাপ আফটার সাম টাইম